All right, so today we're looking at 2-5, and the topic is deductive reasoning. Now, in the previous sections, we had talked about inductive reasoning. Now, let's just take a few moments to kind of develop the difference between the two. So, just a reminder, when we talked about inductive reasoning, now inductive reasoning is when you make a conjecture or a guess about what you think is going to happen. And deductive reasoning, on the other hand, it uses true statements to draw a logical conclusion that is a fact. So the basic difference between the two is inductive reasoning is guessing about what you think might happen. Deductive reasoning, that conclusion arrives at a true statement, a fact. All right? So there's no debating whether the conclusion is true or false in deductive reasoning. Okay? So like, for example, one of the scenarios we used for inductive reasoning was if I see lightning and hear thunder, then my conjecture would be that it's going to rain. Okay? Well, does that guarantee that it's going to rain? Not necessarily. It could clear up and never rain a drop. Okay, so again, remember, inductive reasoning is a conjecture. The conjecture may or may not be true. But with deductive reasoning, okay, the conclusion that you arrive at is a fact. It is true. Okay, because inductive or deductive reasoning uses the following types of statements to arrive at a valid conclusion. So deductive reasoning can use facts, rules, definitions, properties, postulates, theorems, laws, formulas, or any other true mathematical statement or logical statement, I should say. All right? So again, the thing to remember about deductive reasoning is it arrives at a conclusion that is a fact. So there's no debating about whether the conclusion is true or false. All right? So two of those types of statements that is used in inductive reasoning would be the law of detachment and the law of syllogism. Okay, so the law of detachment states this. Okay, if P implies Q and P are true, then Q has to be true. Okay, so if this conditional statement, if P then Q, is a true statement, and P, the hypothesis part of that statement, is true, okay, then the conclusion is that Q also has to be true. Okay, so in symbolism, this would be how it looks. So if P implies Q is true, and the P part, the beginning part of that statement, is true, then the conclusion part has to be true. Like, so an example of the law of detachment would be something like this. So like, for example, let's say that my conditional is, if you add 2 plus 2, then you get 4. And then the next statement is, I add 2 plus 2. Well, then the conclusion is, you get 4. So that's just kind of a quick example. All right? Now, here's the thing that we want to try to make sure that we keep in mind when we're trying to identify law of detachment and law of syllogism. Make sure that you're understanding the pattern probably more so than getting caught up in the statements, right? Because if you can recognize the pattern, then you'll be able to recognize, hey, is it law of detachment or law of syllogism, which is really what we're going to be asked to do from this section. All right, so law of syllogism has a little bit different pattern to it. It says, if P implies Q and Q implies R are true, then P implies R is true. Okay? So in other words, if you have this form, if P then Q, if that's true, and if Q then R is true, then you can conclude that if P then R is true. So it's almost like a chain reaction. So if P then Q, all right, so P causes Q, and then Q causes R to be true, so then you can conclude that P causes R to be true. All right, so it's kind of like a chain reaction, like I said. Now, here's the main thing to remember when you're trying to recognize law of syllogism. Number one, the end of one fact is the start of the other fact. Okay, so the end of one statement should be the start of the other statement. The conclusion of one should be the hypothesis of the other, right? Now, notice I didn't say the end of the first one should be the beginning of the second one, because in law of syllogism, or detachment for that matter, the order of the facts does not matter. So it doesn't have to be, in other words, it doesn't matter which statement is presented first. Both of them are true regardless of the order that they're presented in. So keep that in mind. So again, the end of the first of one fact is the beginning of the other. Okay? And number two, the front drops to the front, the back drops to the back. So once you take out the connecting piece, whatever's left in the front drops to the front, whatever's left in the back drops to the back. Okay? So in other words, if I switch these two, it would still be law of syllogism. So the end of the first can be the beginning of the second, or the end of the second could be the beginning of the first. As long as it links in that fashion, then you've got law of syllogism. That's the main thing that you want to see. First of all, does it have a link where the end of one is the beginning of the other? If it does, then you know P drops to the front of the conclusion, R drops to the back of the conclusion. So let's actually try some of these out now. All right, my directions. Tell if the third statement follows by detachment, syllogism, or if it doesn't follow the pattern of either of these two, you're going to write invalid. All right, so here is my conditional statement. If a number is even, then it is divisible by 2. Okay? The second statement. 10 is an even number. Okay? The conclusion, 10 is divisible by 2. All right, so let's go through and see if we can establish what the pattern is and see if we can figure out whether it follows detachment, syllogism, or invalid. Now remember, don't get caught up in trying to say, well, is that true or is that false? You don't have to worry about that. All you've got to do is you've got to see, does it follow the pattern of one of these two, or does it not follow either one? Okay, so it's really the pattern that you're trying to establish. So let's write out the statements in symbols and see if it matches. All right? So if A is an even number, so I'm going to use E to represent that, even. Then it's divisible by 2. We'll use D, divisible by 2. All right, so that's the first statement. E implies D. Now what's the second statement? Okay, 10 is an even number. That's E. All right, what's the conclusion? The conclusion is that 10 is divisible by 2. That's D. All right, so there's the pattern of the three statements that I have presented here. Now the question is, does it follow detachment, syllogism, or neither one? Well, let's go back and look at our pattern for detachment. Let's try that first. All right, detachment is P implies Q, and the P part is true, then the Q part is true. So if I have a conditional statement and I have the beginning part of that statement, then the ending part has to be true. All right, so I've got a conditional statement. The next statement I have is the beginning part, which is correct, right? And then the conclusion should be the ending part, which it is. So this one actually follows the rule correctly for the law of detachment. So this conclusion would be valid by the law of detachment. It follows the pattern exactly. All right? So that's what we're trying to do. If these two statements were reversed, okay, then it wouldn't. All right? So those are the things that you have to keep in mind. If they had the ending part here, in other words, if 10 was divisible by 2 came as the second statement, and then the conclusion was even, then it would be out of place and then it wouldn't follow it. You've got to have the conditional and you've got to have the beginning part. The conclusion is the ending part of the conditional. All right, what about the next one? Now, the first thing I want you to notice about the second example is it's not in if-then form. However, they are still conditional statements. Why? Because remember what we said. If it can be written in if-then form, it's still a conditional statement. So every square is a parallelogram can be written as if it is a square, then it is a parallelogram. So let's go ahead and write out the pattern. All right, so if it is a square, then it is a parallelogram. The next statement, this is an if-then statement. Every parallelogram is a polygon. So if it's a parallelogram, then it's a polygon. I need another letter. We'll go with PO. All right, PO for polygon. Now, what's the conclusion? Every square is a polygon. That's S implies PO. Okay, now, let's stop right here for a minute and take a look at this. Okay, one thing that I want you to notice is that detachment has only one conditional statement and syllogism has three conditional statements in it. So if you're looking at a pattern that has three conditional statements in it, you know that the answer cannot be detachment. Likewise, if you have a scenario where you've got one conditional statement, you know the answer cannot be syllogism. So that's kind of how it works. What's up, Coach? You good? This is not live. Keep going. All right. So again, on this one, you've got three conditional statements, and so what that means is we know that detachment cannot be the answer. All right. So we need to check to see if it follows syllogism or if it's invalid. All right. So now when we're looking at this, let's look at the pattern for syllogism. And so when I've got the pattern for syllogism here, remember, the end of one statement has to be the beginning of the other. So let's see if that's true. So the end of this statement is P. The beginning of the other statement is also P. So it links up correctly. And now the second thing that has to happen is once you cross out the links, the front drops to the front and the back drops to the back. So I've got my link correctly. The end of one is the beginning of the other. And then the front drops to the front and the back drops to the back. So that is syllogism. All right, so syllogism is correct there. It does follow the pattern correctly for the law of syllogism. Okay? What about this next one? Okay, so number one, I see three if-then statements, so I already know detachment is out. It cannot be detachment. It's either syllogism or it's nothing. So let's go through and see the pattern. Okay, so it says if two angles add up to 180, I'll use 180 for that, then they are supplementary. We use S for that. Next statement, two angles form a linear pair, then they add up to 180. Conclusion. If two angles form a linear pair, then they are supplementary. Now, like I say, you don't have to get bogged down in trying to figure out whether these statements are true or false. That's not really the thing that you need to try to be overly concerned with. All you want to do is say, hey, does it follow the pattern or does it not? Because that's all the instructions have asked us to determine here on this. Okay, so again, the key is write out what pattern you have and then start thinking, okay, does it fit the pattern for syllogism or does it not? You don't have to get bogged down in thinking, oh, well, is that a true statement? I don't know. I mean, you can think about that, and that's good to ponder. But as far as answering the question is concerned, okay, you need to see, does the pattern match correctly or not? All right, so for syllogism, what do we need? Well, we need the end of one fact to be the start of the other fact. Here are my two facts. Is that the case? Well, the end of this fact is not the beginning of the other fact here, but remember, the order of those facts doesn't matter. The end of the second fact is the beginning of the first one. Okay? So as long as the end of one is the start of the other, then you're in good shape. Okay? The end of the second one is the start of the first one. So we're in good shape. Now, what's the second thing? The front drops to the front and the back drops to the back. So the L drops here, the S drops here. This is the correct pattern for syllogism. Okay? So the key to answering these questions correctly is to make sure that you are able to take a look and compare the patterns and see does it fit the pattern or not, yes or no. All right?